Okay, decimals and percents. We talked a little bit about decimals when we were talking about the place values, the tenths position, the hundredths, the thousandths. Well, what does that mean? 0.1 means 1 over 10. That's the tenths position. It has a value of 1 in that position, so it's 1 divided by 10. Okay. 0.23 means 23 out of 100. Tenths position, hundredths position, 23 100ths. I would read that as 1/10, 23 100ths. How about 0.005? I would read that as 5 1,000ths, 5 over 1,000. Okay? If I have a number larger than 1, 2.75, what would that be? Well, that would be 2 as a mixed number, and 75 100ths. Now, of course, we can reduce 75 100ths, but just to write that decimal as a mixed number, that's what we would do. Okay? How about converting between fractions and decimals? If I wanted you to take the fraction 2/5 and turn it into a decimal, well, it's 2 divided by 5, right? Pardon my squeaky chair, by the way. It's 2 divided by 5. Bust out the calculator, be the easiest way, or do longhand division, but 0.4, 2 divided by 5. Mixed number, 2 and 3/4. Well, 3 over 4 is a fraction of 0.75. Maybe we have that one memorized, maybe not, but 3 over 4 is the fraction of 0.75, so it's going to be 2.75. Okay? Now, to go the other way around, decimal to fraction can be a little more difficult, but if I have the decimal, 0.86, and I want to turn it into a fraction, well, how would I read that? I would read that 86 100ths, right? Write it down just like it reads, 86 100ths. Well, now we should really reduce the fraction, though, right? So now we're playing around with vectoring and things like that. Let's see, 43 times 2 is 86. 50 times 2 is 100. I think we're going to get away with just that little step there. So it would be, excuse me, not 45, 43 over 50 as a reduced fraction. Okay? Alright, bigger ones, if we had, 0.235, you know where we're going with this, that's 235 1,000ths. Okay, might be a little more challenging to reduce that one. Okay, we would have to see what we can do here. Well, we know, what do we know? We know we can divide by 5 anyway, right? Let me bust out the calculator here for a second. 235 divided by 5. It's 47. And then 1,000 divided by 5 would be 247 is prime. So yeah, that should be it. Oh, okay. Wasn't so bad at all. So I divided by 5. I didn't show it as factoring and canceling, but I divided by 5 top and bottom, and that's how I got that reduced fraction. Okay? All right. I mentioned earlier, if you're adding or subtracting decimals, simply line up the decimal point. 2.34 plus 8.56. I simply line up the decimal point and I bring it right on down to my answer. Okay, and then I work my magic here. 10.90. Same thing with subtraction. Okay, line up the decimal point, bring it right on down to the answer. Okay, multiplying and dividing decimals is a little more to it, and I don't want to do a longhand excruciating multiplication problem here, but if I had 23.74 times 16.5, I don't have to line up the decimal because I'm just going to, if I were to really do this old longhand multiplication, you remember how this can be. We'd have a all big string of numbers down here, and then eventually we'd add all those numbers together, right? And when we add those numbers together, we're going to get 391710. Okay, Then we have to figure out where the decimal goes. And how you do that is you would count. You know, from here it would be 2 positions back to get to that decimal, and 1 position back to get to that decimal. So 3 total shifts. I got to go here. 1, 2, 3 total shifts. So the answer would be 391.710. Okay? Of course, with all these, we are absolutely encouraged to use our calculators. We will be giving calculators on the exam. I'll talk a little more about that in another video. But yeah, 391.71. Calculator is going to drop the trailing 0, and that's okay. 391.71. Okay. All good there. What about multiplying by powers of 10 real quick, and then we'll divide decimals. You know, if I wanted to take 45.26 and I wanted to just multiply it by 10, all we're doing is shifting the decimal, right? 1 place to the right. So that'd be 452.6. 1 decimal position to the right. What if I took 123.456 and I multiplied it by 1,000? Well, now that's 3 powers of 10, 3 decimal shifts to the right. Like that, we go back 3 places and stick a comma in there, 123,456. Okay, so whatever it is, we're going to multiply by when we're multiplying by powers of 10, we're going to shift that decimal to the right. Let's do one more. 47.2 times 100. Well, I got to move 2 places to the right. Well, what is that going to do for me? 1 place gets me past the 2. I need to go 1 more place and fill in that 0. 4720. So 4,720. Sometimes we need to fill in that 0. If we're multiplying by small powers of 10, okay, and we're going to talk a thing called negative exponents, you know, and exponents in general in another video, but if we look at just the decimals like the ones we just looked at a minute ago, if I have 45.67, let's say, and instead of saying times 10, I'm going to say times 0.1. Okay, 1/10, right? We said 0.1 is the same as 1/10. Let me write that up to the side. Well, that's the same thing. That's the same thing as dividing by 10. Multiplying by 0.1 is the same thing as dividing by 10. Okay, let me show it even more explicitly. Times 1/10 times 0.1, right? Slap a denominator of 1 under it there, okay? And now it becomes what I wrote over here to the left, 45.67 divided by 10. And when we divide by powers of 10, we shift that decimal to the left. So it's going to be 4.567, okay? 6.29 times 0.0001. Ooh, now what am I going to do? Well, 0.0001, what did we say that was? Tenths, hundreds, thousandths, 10,000ths. That's the same thing as saying times 1/10,000. Slap a denominator of 1 under there. I know I'm using a classic time sign for my times when I said we don't really do that in algebra, and we don't, but I'm doing it here, I guess, so bear with me. That means that decimal is moving 1, 2, 3, 4 places to the left. Okay? The first place gets me past the 6. I need to fill in 3 leading zeros, and this 0 before the decimal doesn't count as a leading 0, but I like to have a 0 before the decimal. 3 leading zeros, and then my 629. Okay, there we go. Alright, powers of 10. Alright, general dividing of decimals though, again, calculator is our best friend. If it's dividing by a power of 10, we're just shifting the decimal. Okay, that's pretty easy. But if it's not some power of 10, like if it's, 0.625 divided by 0.25, let's say, for example. If we wrote it in classic longhand division style, it would look like this. Okay, and what we do when we have a decimal out front is we would just count spaces. 1, 2 spaces out front would make that a 25. So 2 spaces over here would make that a 62.5. Okay, so we can make that little correction. I can call it a 25 out front and call it a 62.5 inside. Okay, so now there's no decimal out front. Now the decimal just comes straight up. Okay, so when I have a decimal out front like that, I need to shift it over to make it a whole number. How many decimal shifts I shifted there is the same number I need to shift inside, and then I move it straight up. Okay, so it's really just 62.5 divided by 25. Move the decimal straight up. Now we just got to figure out what we're going to do here. 25 goes into 62 twice. Multiply back across, we'll get a 50, and we'll get a 12 as our subtraction here, but then remember we bring down the next piece, so bring down the 5. So now I got to ask myself, how many times does 25 go into 125? 5 times, and this one's going to get a nice clean remainder of 0, so it's just going to be 2.5. Okay, again, calculator is our best friend. Plug that right in the calculator, you're going to get the same thing a lot easier. Okay, no need to do longhand multiplication and division here, Okay? Alright, so decimals. What about percents? What do we mean by percent? Percent really means per 100. Okay? Like century, per 100. Okay? 87% means 87 per 100. 87 divided by 100. And I know sometimes I put the little slash in my 7 and sometimes I don't. I apologize. 87 divided by 100. Of course, we could turn that into a decimal. Would be 0.87. Okay, all these are 3 different ways to say the same thing. 87% means 87 out of 100 means 0.87. Okay, all good there? What about something smaller like 3%? Well, that means 3 out of 100, and that means I got to stop and think a minute now. The decimal's here, it's going to go 2 places to the left, 0.03. Okay? So in order to go from a percent to a decimal, from percent to decimal, move the decimal 2 places to the left, and drop the percent sign. Okay? 62%. Move the decimal 2 places to the left. Drop the percent sign. 0.62. 54.9%. 2 places to the left. 0.549. Drop the percent sign. 127.6%. 2 places to the left. 1.276. Drop the percent sign. 0.048%. 2 places to the left, so 2 more leading zeros, so 0.00048. Drop the percent sign. Okay? So from percent to decimal, I move that decimal 2 places to the left. If there's no decimal showing, it's at the end of the number, right? I move it 2 places to the left, and I drop the percent sign. So if I'm going back the other way, it's the reverse. I'm going to take that decimal and move it 2 places to the right and slap and tack a percent sign back in there. So if I have, 0.23, 2 places to the right, 23, put the percent sign back in there. 0.419 is going to be 41.9%. 0.00031 is going to be 2 places to the right, 0.031%. Okay? All good? 1.47 is going to be 147%. You can have percents bigger than 100, right? I mean, in some contexts that doesn't make any sense to do more than 100%. If you're talking about a quantity of something, you can only have 100% of that something. It wouldn't make any sense to say you have more than 100% of that something. But if you're talking about a percent increase or a percent decrease or something, you can certainly have more than 100%. So don't ever think you're limited to from 0 to 100 when talking percents. By no means. Okay, 23.6 as a percent. 2 places to the right. 236. I gotta slap a 0 in there, and I ran out of room. I'm sorry. Percent. 2,360%. Okay. All good. So to go between decimals, percents, and fractions, not too shabby, right? All right. There are some basic percent problems out there, okay? And most textbooks dive into those problems right now, and I don't want to do that, okay? The question being, what is, 12% of 87, question. Or 24 is 8% of what? Or 16 is what percent of 89? Okay, there's 3 different questions I just asked there. There's 3 unknowns at work here. What? 1, 2, and 3. 1, 2, and 3. 1, 2, and 3. 2 of them have numbers. The other one I had that question, that word what, or in the last case, what percent. Most texts have this little formula where we got a P, a B, and an R. Okay, a proportion, a base, and a rate, and then depending on how the question is asked, it's either a multiplication or a division problem, and some texts have little pictures that kind of help you remember which way to go and all that. I found it so much easier to just apply a little algebra to solve these questions, these 3 questions. So we're going to wait until we talk more algebra to answer those, because most texts really, if you ask me, make it so overly complicated with this whole PBR business. Then if you just translate, okay, it takes a little skill here. We got to translate this written word into an equation, and then we have to solve the equation. Okay, it sounds like a lot, but it's not. Trust me. Okay, so hold off on answering these 3 questions, and by the time we get to it, I'll have 3 slightly different questions. I just pulled those numbers out of the air, but same basic idea on how to ask that percentage question, okay? All right, we will pick up with some basic rules of algebra in the next video.